Tech Talks Education. Welcome back. We have been looking at how to detect cations using reagents in solutions. So I want us also to try to see, for the sake of our good consumption, let us look at how we can distinguishing between cations in solutions. I want us to remember that we have had a look at very many solutions of reagents that we apply to a solution of a cation, and then we get specific observations. Now, some cations gives us the same observation with some reagents. Now, how best can we distinguish between those cations? It is like having identical twins. You don't know who is older than the other, who is the elder, who is the younger, unless otherwise you perform some kind of a test on them. In this case, I can call them by names. One of them will come up and respond, another one will keep quiet. So if I say, I call the elder one, the name given to the elder one, in this case, that elder one will have to respond, and I know that, oh, this is the elder, this one who is quiet is the younger one. That's what we are also going to do here, and we are going to start by distinguishing between calcium ion and the magnesium ion. So, in this case, we normally use this one here so much. It is asked for so much in our paper 2 theory paper. They ask you to name one reagent that you can use to distinguish between the following pairs of cations. They give you the pair of cations, and then they ask you to state what you would observe if each of those cations was treated independently or separately with that very reagent. So I want you to see here, we have a pair of calcium ion and magnesium ion in solution. Remember, we are dealing with cations in solution, and we want to see how we can distinguish between these two. So we are supposed to choose a particular reagent, and that reagent should make sure that when we treat each of these cations with that same reagent, we get different observations. So let us see the reagent that we can use in this case. We need to choose carefully a reagent that will make us get different observations. Let us see sodium hydroxide solution. Can we distinguish between these two using sodium hydroxide solution? It is impossible, because both of them give us a white precipitate insoluble in excess. What of ammonia solution? Yes, calcium ion gives us no observable change, and magnesium ion gives us a white precipitate insoluble in excess. So we can use, one of the reagents that we can use can be ammonia solution. So let us see, calcium ion will give us no observable change. Good. What of magnesium ion? With ammonia solution, we know how it is applied, dropwise until in excess. That's how we apply it, that's how we test. So this one gives us a white precipitate insoluble in excess. Perfect. So ammonia solution makes us get different observations with these two cations here when we treat each of them with the reagent just differently. So it's a good reagent for distinguishing between calcium ion and magnesium ion in solution. Another reagent that we can use can be dilute sulfuric acid or a solution of a soluble sulfate salt. So let us again come here, starting with calcium ion. We must have at least different observations. So calcium ion is going to give us a white precipitate. Meanwhile, magnesium ion will give us no observable change. In this case, when we use dilute sulfuric acid, we had seen that the calcium ion in the solution under test will combine with the sulfate ion of the dilute sulfuric acid or a solution of a soluble salt sulfate salt. They combine and form insoluble calcium sulfate, which will be formed as a white precipitate. The same thing happens here, that the magnesium ion, which is in the solution under test, will combine with the sulfate ion provided here, and we get magnesium sulfate. But magnesium sulfate is a soluble sulfate salt, and for that reason it will not be precipitated. We shall have it formed as magnesium sulfate solution. That's why we get no observable change. In other words, no precipitate forms. So I don't want you to be able to forget this. And these are the two suitable reagents. Now let us look at another one. Supposing I have magnesium ion and let me say and the aluminium ion. I hope you can remember how we can test for magnesium ion and aluminum ion, where they belong when we are using sodium hydroxide solution. Let us look at the suitable reagent in this case. Our suitable reagent in this case is the sodium hydroxide solution. Sodium hydroxide solution, whereby the magnesium ion with sodium hydroxide solution, it gives us a white precipitate insoluble in excess. Perfect. Meanwhile, the aluminium ion, as part of zinc and aluminium ion led to ion ZAP that we saw with sodium hydroxide solution, we get a white precipitate soluble in excess to form a colorless solution. So that is that with the distinguishing between magnesium ion and aluminium ion. Let us look at another one. I believe that we are following. In this case, we are now applying the knowledge that we have got from testing for cations or detecting cations using different reagent solutions. So let us look at the next one. That is, if we are trying to detect, distinguish between magnesium ion and the lead 2 ions. Let us look at the reagents. The first reagent that we can be using in this case, or that we can use, is sodium hydroxide solution. So, the magnesium ion, as we know, will give us a white precipitate insoluble in excess. Then the lead 2 ion forms a white excuse me, a white precipitate soluble in excess to form a colorless solution. We can also use another reagent, by the way. That's why you can see me having A. There's another B for this. We can now use the confirmatory reagent that we use for testing for lead 2 ion. That is it. We can also use potassium iodide solution. And in this case, we just apply a few drops of the reagent to a solution containing magnesium ion and then to a solution containing lead 2 ion separately or independently. Now let us try to see. In this case, the magnesium ion will give us no observable change. And then the lead 2 ion, we expect it to give us, as we have seen, a yellow precipitate. A yellow precipitate. So it is a confirmatory reagent for lead 2 ion, and we can use it for distinguishing between lead 2 ion and magnesium ion. Let us try this also. Try distinguishing between aluminium ion and the lead 2 ion. Try distinguishing between copper 2 ion and the iron 3 ion. Try distinguishing between iron 2 ion and the iron 3 ion. Please also try distinguishing between magnesium ion, this one is now number 7, magnesium ion and the calcium ion. Please let me add you one more, that is zinc ion and the lead 2 ion. Please try all these ones here at your own free time, but remember it is an application of testing for the cations. So those reagents, we can use them, and then if we use them for distinguishing between these cations here, they must be able to give us different observations with each cation. So this is Step Docs Education. Thank you for watching our ionic chemistry and qualitative analysis, detection of cations, and we are distinguishing between the cations, pairs of cations given, and you will meet this one so much in our chemistry 545/2, that is paper 2 in UNED. Thank you for watching.